You need, because gamma distribution is complicated, and we need to first understand a gamma function. I'm going to say this again. There's a difference between a function and a distribution. Okay? So for you to be able to understand, the gamma distribution we want to talk about, then you need to be able to understand gamma function. Okay, now let me tell you, do you know that gamma distribution and exponential distribution are related? I'm going to say the same way Bernoulli and binomial are related, the same way geometric and negative binomial are related, exponential distribution and gamma are related. Okay, I'm going to say this gamma distribution is a generalization of exponential. Why exponential distribution talk about the waiting time before the occurrence of an event? The gamma distribution is going to talk about the waiting time before the occurrence of multiple events. Does that make sense? Okay, so, and that is what gamma distribution actually talk about. So but before you before we talk about this gamma distribution, like I said, we need to talk about gamma function. Okay, we need to talk about gamma function in order for us to be able to save our time from rigorous mathematical complexity. An idea of a gamma function can be used. Okay, now take a look at this. What I'm going to give you right now, I'm going to give you properties of a gamma function, and not only that, I'll first give you integral definition of a gamma function. Integral definition. Okay, I'm also going to give you non-integral definition. Okay, I'm going to give you integral definition. Okay, so when I write this, gamma alpha, okay, is the same thing as is 0 to infinity, s raised to power s raised to power alpha minus 1, okay, exponential raised to power that ds. Okay, so what you are seeing here now is what we call integral definition. Okay, do you know that when you are in your high school, if you come across something like this, okay, if you come across something like this, I want to believe you'll be thinking of using integration by part. Has anybody heard about integration by part? Oh my God. Using integration by part for this is going to take forever. Okay. But do you know that if the range of the integration is from 0 to infinity, the idea of a gamma function can be used. Now, for instance, okay, if this is gamma alpha, this guy is going to be gamma 7. Okay, the value that I see here, I'm going to add 1 to that. Alpha minus 1 plus 1, that's gamma alpha, right? Okay, now, and you know what? That is going to be equal to the non-integral definition. That will be equal. Take a look at this. For the non-integral definition, okay, gamma alpha is alpha minus 1 factorial. Okay, if I want to speak in a mathematical language and I don't want others to or maybe researchers in other fields to understand what I'm saying, okay, do you know that what I mean here? This is the same as 6 factorial, okay, which is 120. So the whole of this guy now, when I solve it, is just going to give me 120, okay? Sorry, 120? Sorry, not 120. 5 factorial is 120. That will be 120 times 6. Okay, so it's going to give me 6 factorial. So take a look at that. This is the non-integral definition of a gamma alpha. This is an integral definition. But you know what? Integral, which means is 0 to infinity. this raised to power this and this, the S is the same as gamma alpha is the same thing as alpha minus 1 factorial. That's what I mean. So, and that's exactly what we're talking about here. Okay, now when you take a look at this, gamma n is n minus 1 factorial, just like what I said. And gamma alpha, do you know that gamma 6 is the same thing as 5 gamma 5? Okay, gamma 6 is the same thing as 5 gamma 5. I can keep going. Okay, what about this? 4 gamma 4. I can keep going. 3 gamma 3. If you take a look at this is like a factorial. Do you see that? Okay, now, and another, we got special one. Take a look at this guy. Gamma 1. Okay, gamma 1 is 1. Okay, and do you know that gamma 1, if I want to go by this definition here, you know, somebody has the other time about 0 factorial. You know, you remember? Can you hear me, right? Can you hear me? You know, you had the other time about 0 factorial, right? It's actually here. Let us use this now. If alpha is 1, what happened? If alpha is 1, if alpha is 1, right? 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 And what is gamma 1? That's 1. That's why 0 factorial is 1. Does that make sense now? So gamma 1 equal to 1. Because if I put 1 here, if I put 1 here, this is gone, right? What am I gonna have? I'm only gonna have this. Right? Integrate that. This guy is the same thing as gamma 1. Okay? And when I integrate this guy, you know, integrating this guy now, it's just going to, if I have this guy, it's just going to be this. Right? And if you plug in that, minus, minus, right? This is 0. Minus, this is 1. You see that? So that is the reason. Okay. Now that we understand gamma function, then we can go to gamma distribution now. Before you can actually understand what to do in gamma distribution, you need to have the idea of a gamma function. And the same thing when we get to beta distribution, we also need to understand a beta function. Does that make sense? Is there any question? Any question? Okay. I want to